It's a lot faster too. Okay, let's get started. So we're talking about this. It's been a weekend, it's been a couple days. Let's just start off with some review before we jump off into harder stuff. So here's this function that we graphed, which was the volume of this box after we cut out the squares and folded up the flaps, right? And what was that volume formula? Length times width times height. So what was our length? So the length of the paper was 11, but then the box is going to be less 2x because of the squares that we cut out. And then the width of the paper is 8.5, but we cut out the 2. So we've already done this, right? And then we decided to call this volume F, right? So then rather than it is equal to V, that's true, that's the output quantity, but we said let's call it function F. So it looks like this. Is that F times X? No, F is what? F is the name. It's the name of our volume function. We're calling the volume function, we're calling it F. What's in the parentheses is? It's the whatever, yeah, it's the input into the function. And so by saying x, we're saying we're letting that input take on many values. And in this case, what do those many values represent? What was x in this function?
Length of the cut.
Length of the cutout in inches, right? And then over here, we called this this is the rule. We take the input, if we apply, this is a set of instructions. That's what the rule is. It's a set of instructions, what to do with the input. And when you follow those instructions, you get output, which in this function is volume of the box. So I want you to, as a warm-up here, so using this f of x function, which is our volume function given the side length of the square cutout, how would you represent symbolically the volume of the box when the cutout is 0.5 inches? And then how would you represent? How does that get represented on the graph? Okay, and then similarly, how would you represent the change in volume of the box when the cutout starts at 3 inches and is increased to 3.5 inches? So get a partner, just to get us reoriented with where we were doing Friday before we kind of start, and take a couple minutes and see what you come up with. I gave you a third one. All three of them. How would you represent it symbolically? How would you represent it on the graph? Take 2 more minutes. So really dig in. Get a piece of paper. Write your answers down. Talk about your answers. Think about it. Pretend it's the test. Take it seriously. Got all your answers? This is it's a mock quiz. See how you're doing. Take it seriously. Okay, symbolically, what's the volume of the box when the cutout is 0.5 inches? No, symbolically. I'm not asking for the value. I'm asking to represent it. I'm asking you to represent it. How do we represent that value, the volume, when the cutout is 0.5? So what do you write? F of 0.5. Yeah, we could put it in the rule too, but we don't need to. That's enough. That's it. That's it. That right there is the volume of the box when the cutout is 0.5. That's what it is. That's what that means. Okay, how do we represent it symbolically on the graph? Or sorry, on the graph?
You go up to 0.5 and then make a line goes up. Corresponding point.
I got an advantage here. If I can handle it. Let's see. Come on. There we go. Now I need to find my... There. Okay, so what about graphically? How is it represented, the volume, when the cutout is 0.5? There's kind of a couple ways you could do this. You could just say, it's this number right here. That's f of 0.5, whatever that is on the y-axis. Or we could say, it's this length right here. f of 0.5. Does it make sense? Both of those are showing the volume of 0.5. Okay. The change in the volume when it starts at 3 and increases to 3.5. So now what is the change in the volume? Yeah. She wants f of 3.5 minus f of 3. And then, okay, good question. So is it f of 3.5 minus f of 3? Or is it f of 3 minus f of 3.5? We want the change if we're starting at 3 and ending at 3.5, and we want the change. How many people think it's what I wrote? How many people think it's the other way? The rest of you, what do you think? Doesn't matter. Okay, so let's think about this. Let's take each one separately. What is f of 3.5? How would we represent that on the graph? Let's use the graph to answer this question. Okay, so how would we represent that on the graph? We'd go to make the cutout 3 inches. Please land on it. Please, please. There, okay. So what is f of 3? F of 3 is, that's kind of the same as that one, isn't it? Did you already calculate it? Okay, so f of 3 is this y value, 37.5. Oh, right, we got the measurements too here. And that's our f of 3, right? Okay? Now, if I do f, there we go. Now I got f of 3.5. And that tells us that it is 21. So if we want the change from when it started at 3, start at 3 and go to 3.5, if we want that change in volume corresponding to increasing the cutout length from 3 to 3.5, do we want f of 3 minus f of 3.5 or f of 3.5 minus f of 3?
F of 3 minus f of 3.5. Your slope is decreasing. Your length.
How many vote for f of 3.5 first? How many vote for f of 3 first? What happens to the volume when we increase the cutout length from 3 to 3.5? What happens to the volume?
Decreases.
Decreases. So the change should be negative. So what should it be?
3.5.
This is right. What is the value? It's negative 16.5. The change is negative. The volume goes down when we're increasing the cutout length here. So to get a change, to get the change starting at 3 and ending at 3.5, we're going to start with the end. We're going to do final minus initial, right? We're going to do final minus initial, which gives us the change. You know, if my height is 72 inches today and 75 inches tomorrow, am I going to subtract 75 minus 72 to get my change, or 72 minus 75? I'm going to take the final height minus the initial height, right? To get that change, which is positive 3. In this case, it's going down. So we take final minus initial, and we get the amount of decrease, 16.5. How is it represented on the graph? Started here, ended where the dot is now. So how do we represent that change? Is it this horizontal line? Does that represent the change in volume?
No.
No, that's the change in x, which is? What is the change in x in this case? 0.5. Corresponding change in volume is right here. So this is delta, we could say delta V, or we could say delta F. Both are good, and that delta V or delta F is this right here. F of 3.5 minus F of 3. So the representation is this vertical line. This vertical line is that representation of the change in volume. Okay, the cutout length required to achieve a volume of 60 cubic inches. Anyone think they got this? Okay, I'm going to call, so X we're going to just reserve for all values. So can I say A? Did you put this? That represents the cutout length. I'm calling it A. We could call it C. That results in a box of 60 cubic inches. How do we represent it on the graph? So we look for the volume, and we get 60, right? This is that's probably the closest. The closest I can get right there is 59.81. So it's showing up here that. Here's your 60. So how do we represent the cutout length? Where in this picture represents the cutout length that gives me that volume of 60? Right here. From here to here. This is my value of A. That cutout length right there is going to give me this volume of 60. Are we done? Is that it?
Because there's one more 60 that you can achieve.
Oh, tell me. What now?
Well, because there's 2 points on the graph at which the volume of the box is 60.
He's on to something. There's another place. Let's see how close I can get. That's about close enough. There's another place over here where we know the volume goes up, and then as we keep increasing the cutout length, it goes back down again. There's another volume on the way back down that hits 60. So there's actually two values of A. So that would be represented. So we've got like A1 and A2. And that would be represented by this right here. The cutout length that would end up with 60. So this has two solutions. Questions on the warm-up? Okay, so here's what I want you to work on. I'm going to do notebook check, and I got lots of work for you to do. Go slow, get a partner, talk these out. They get progressively harder as you go, and I guarantee they're going to challenge you, okay? Here's what I want you to do. Read carefully. Page 90, 3A and 3B. You might have already started those from last time. Page 93, that's most of what we're going to be working on. All of it. But for 2D, I want you to change it. Split it up into two different questions, 2D. Instead of representing the combined change, just represent the change of each city. Do two different questions. So represent the change in Pasco's population, then continue as it continues, and then represent the change in Richland's. And then if you happen to get through with that, which you probably won't, it's going to take a while, then page 94, 3, and 6. Questions on what you're doing for the next 20 to 25 minutes? Okay. Some of these are challenging, but they're important. So think, work together, talk them out. Okay? Get a partner. I'm going to highlight in red. Okay, let's look on page 90. F of 1.2 minus F of 0.5. Who thinks they've got a really good, precise, complete statement on what F of 1.2 minus F of 0.5 is? Who wants to give it a shot? Yes, ma'am. Yeah, without performing calculations, interpret the expression. That's right.
Change volume from 0.5 to 1.2 in the link.
Okay, so switch some phrases around there. It'll help. So that what it's change in volume.
1.2 to 2.5.
No, you had it right. It just was kind of confusing because you took the phrases and switched the phrases. So you said the change in volume, and then you just started saying numbers. So that's what's difficult. That kind of makes it a little confusing. So it's the change in volume when what? There you go. So do you hear what she said? The change in the volume when the length of the cutout starts at what? 0.5 and increases to 1.2. Is that what you guys wrote? Okay, so I think B is pretty similar to that. Okay, I'll just let you keep going. So everyone should be on page 93 by now. Okay? They get second half of that page. Make sure you're talking those out and agreeing with the person next to you. Those are a little harder. Okay. Let's give it a shot here. So, what is F of 2.3? F of 2.3, very specifically. You're gonna
2.3 years from January 1st, 1990. So 1992 March 1st.
Okay, 2 years. So F of 2.3 represents 2.3 years from January 1st, 1990.
Of past population.
It's a population, right? So you got the time is perfect, but it's this is the population at that time. Okay? So what would B be? F of negative 1.5. So that whole expression represents
The population 1.5 years before the initial reference.
he wants the population 1.5 years before January 1, 1990. So when would that be? June 1st, 1988. June 1st, 1988. So this whole thing together represents the population June 1st, 1988. Does it make sense? Okay?
What should we write? Should we write population of the past 1.5 years, or should we write the actual date?
Either would be okay. So as long as you said 1.5 years before January 1st, 1990, that's cool. Or you can write June 1st, 1988. Both are good. Okay, how about F of 4 minus F of 2? How about back 2 rows? Anyone back there get it? F of 4 minus F of 2.
Is it the change in the population?
All right, she started to say it. So yes, go ahead.
Change the population. From 2 years to 4 years after.
So what dates would those be? From what date to what date? Uh-huh. She got it. So it's the change in population starting January 1st, 1992, ending January 1st, 1994. And it'd be the change in population over that 2-year period. Does it make sense? Okay, how about F of 2 plus H? Somebody knew. What do you think that was? F of 2 plus H. Yes, sir?
The population of Pasco 2 and the number of years after January 1st, 1990.
Okay. He said the population of Pasco 2 and some other number of years H after January 1st, 1990. What do you think? It's good? There's another way to do this one. Anyone think? Yeah.
The population of Pasco, Washington, some number of years after January 1st, 1992.
Did you hear that? So the population of Pasco H years or some number of years after what date? January 1st, 1992. Either are fine. So 2 and a number of years after 1990, or H years after 1992, January 1st. But again, it's a population, right? F of the number, that's always a population. Okay, so now we're getting, so there is a rhyme or reason to these expressions that they're picking. This is very involved with calculus. So what about f of 2 plus h minus f of 2? Somebody new. They can get this one. Yeah?
Would it be, I have a question about this.
Sure. Yeah.
Would you say that it's just the population a number of years after 1990, or would you say a number of years after 1992 multiplied and then subtract 2 off of that?
So remember, what kind of thing do we get if we take like a population at some point in time and subtract a population at an earlier point in time? What kind of quantity do we get? What do we get? We get a change in population. We get a change in population. So we want to know what, so this is the change in population. See the hand on there? Not intentional, you know? Sometimes life gives you little surprises. Okay, so it's a change in population. What change in population is it?
Change
From
some years after 1999 or 1992.
from 1/1/92 to,
January 1st.
does it have to be January 1st? How long is this time change over which we're measuring the population change? H years. So we could say 2H years later. Okay, so does it equal f of h? Does it equal f of h? What does f of h represent? Let's flesh it out here. What is f of, this is a great question, and it's something that students do all the time. What does f of h represent? Is this a change in population or a population? Just f of h. That's just a population. What population is it? This is the population of Pasco h years after January 1st, 1990. Okay, yeah, if h was negative, yeah. So as long as h is positive, this is a population change starting, or it is the population h years after January 1st, 1990. Is that the same thing as the change in population over the h year period starting in 1992? Is that the same? Could be a different change. They're both h years long, but this one starts when? 1990. It's just the population, you know, it's h years after 1990. This is the change of population from January 1st, 1992 over an h year period after, starting January 1st, 1992. Totally different. So it's not the same. They're not equal. They're not equal. We've talked about that in previous classes, that doing the difference of the two is not the function of the difference. Doing the difference of two function values is not equal to the function value of the difference of those inputs. It's not good. Okay, so what if we took that change in population and divided by the number of years? Right, that would be the average change per year in population. Oh no. Average change in population per year over how long of a period? H years, starting 1992. Okay, I highly recommend that you also keep, in fact, let's add that to your homework, is to finish the ones that I had assigned in class. Can I put those back up? We need the practice. So starting with number 2. What I've highlighted there. Starting with number 2 on page 93, number 3 on page 94, and number 6 on page 94. Do those in the book. Do those in the book. Maybe you have this homework too. Did everybody get the graded homework back? Anyone not get graded homework? Where is the rest? Up there. Or just leave it right there. Yeah. Anybody else not get their homework? Yeah. Let me turn this off.